Okay, so this is chapter 8, which is all about fingerprints. So we'll keep going here. So, of course, there's a little bit of history in the first part of it. So, the history of fingerprinting. In 1892, Francis Galton, he was the person that wrote the classic textbook that I think is still used called Fingerprints. So he went through and he kind of noticed how they're different between everyone, and he started writing about it and trying to organize it. But the next thing they needed to come up with was like how we know that everyone's are different, but how do you use them in an organized manner? So how could you systematically look at them? How can they be categorized? So Dr. Juan, and I'm not sure how you're supposed to say his name, Fus, Vucitic, devised a classification system that was used in Spanish-speaking countries. And then Sir Edward Henry, he devised a different classification that was used in most English-speaking countries. So we couldn't agree on it, but that's how they started doing it. And there's more in the book about it. So in 1903, if you guys remember from chapter 1 that we talked about the Bertillon system. So the Bertillon system, remember, he did anthropometry where you would measure all the body parts, and he believed that you could distinguish between two people based on their physical characteristics, just like how long their arms were, their hair color, all that kind of stuff. But there was the case where there were actually two prisoners at Fort Leavenworth. So one person was in prison there, another one was coming into prison there, and they both were named Will or William West. And they looked almost exactly the same, so they looked like twins. So at that point in time, they decided that Bertillon's anthropometry was not super effective, so they were able to distinguish between the two men using fingerprints. So that was kind of like maybe one of the last straws of the anthropometry. Okay, so in 1901, the New York City Civil Service Commission used fingerprinting to identify its employees. So that's where it started. In 1904, the Scotland Yard came to the United States, and they started training U.S. police in how to fingerprint and how to interpret the fingerprints at the World's Fair. And then in 1924, the FBI was reorganized, and they started collecting fingerprints in there. So the FBI has the largest collection of fingerprints in the world. Okay, now, fingerprint principles. Let me see what I'm like. I try to number these things, and then it loses it when I transfer the file into the thing I use to record. Okay, so fingerprints are a reproduction of these things. They're called friction skin ridges that are on the palm side of your fingers and thumbs. So you guys get that. You know where they're at. Okay, so there's three basic principles that underlie the use of fingerprints. So the idea is no two fingers have been found to possess identical ridge characteristics. Okay, so no two fingers have the same friction ridges of all the fingers that they've looked at. So that's an individual characteristic. Okay, fingerprints don't change during your lifetime. Okay, so they just get bigger. They don't change any other way. And then they've organized them into these general ridge patterns so that you can systematically classify them. So there's a way to organize them and compare them. So 1, 2, and 3. So no two fingers are the same. They don't change. They develop like when you're a fetus, and then there's a systematic way that it can be classified. Okay, now, principle 1 is that there's no two fingers that are the same. So mathematically, the probability for the existence of two identical fingerprint patterns in the world's population is really, really small. So Galton, he calculated the existence of 64 billion different fingerprints. So that's a lot of fingerprints. Now, of the millions of individuals who've had their fingerprints classified, so far they haven't found two that are identical. Okay, now, the individuality of a fingerprint is not determined by its general shape or pattern, but by looking at the ridge characteristics, and ridge characteristics are also known as minutia. Okay, so ridge characteristics are things like, are they, well, we'll talk about it in a second. Okay, so now each finger could have up to 150 minutia on it. Okay, so there's 150 different things that could be on there. Okay, so it's kind of crazy. Okay, now, common ridge characteristics or minutia are things called bifurcations. Okay, so bifurcation is kind of like a tree branch. It's something that splits. Okay, so bi is two. Okay, ridge endings, those are where the ridge actually stops. So that's not too profound. Ridge dots, they kind of make sense, right? So it's like a little, just a spot. And then enclosures. So an enclosure is a place where two ridges come together and there's a space in between it. Okay, now, remember when we talked about CODIS and DNA, remember we said you had to have 13 characteristics that had to be the same in order to say, yes, this is definitely that person. Okay, now with fingerprints, they haven't decided on a minimum number of ridge characteristics or minutia that have to be present in both fingerprints to say it's positive. Okay, so let me repeat that again. So currently in the U.S., there's no predetermined minimum number of ridge characters that have to be present in two impressions in order to establish positive identification. So they haven't, some people say 8, some people say 16, so they haven't come up with a solid number that they have to match. Okay, now, in a judicial proceeding, okay, the expert is going to demonstrate point by point the comparison so that you can see that they actually match. So this is a picture, it's a diagram of a fingerprint, and it's got some things pointed out on it so that you can see them. Okay, so a ridge ending is where a ridge or a line, right, actually stops. Okay, a bifurcation, so remember bifurcation is 2, so bifurcation is where something either branches or comes together, so kind of like a tree branch that splits. A ridge is just the raised part. The ending is the end of it. A ridge island or a ridge dot is just a little tiny spot where there's like a fragment or an end of a ridge. And then an enclosure is where two ridges come together and there's a space in between it. Okay, now this is a picture. It's a fingerprint exhibit illustrating the matching ridge characteristics between the crime scene print and an inked impression of the suspect's finger. So it has things numbered on it. So there's bifurcation that's numbered. Here's on two, so you have two things that you're comparing so that you can see hopefully how they match. It's kind of hard to see, but so there's bifurcation. So where it comes together, let me see if I can make a different color. So there's a bifurcation, there's a bifurcation, so they match. Number 2 is a ridge ending, so you can see where it stops, sort of. 3 is an enclosure, so there's an enclosure, there's an enclosure. 4 is another ending, and they match on both diagrams. 5, 6, 7, those are all bifurcations, so places where they split, and they match. So you can kind of see by looking at them, you see the similarities, and you can kind of see what they're looking for. Number 10 is it's a short ridge, so it's just this little short It's a not very long ridge. There's another ending, but you can see how they're similar and how they're different. Okay, now principle 2. So this is kind of about the anatomy of the skin and how we get these friction ridges. Okay, so the epidermis is the outer layer of our skin, so that's what we actually touch, and then the dermis is the inner layer. So the dermis is below that. The dermal papilla, so a papilla is kind of like a bump. So that's the layer of cells that's between the dermis and the epidermis. Now, the dermal papilla is what determines the form and the pattern of the ridges. So the papilla develop in the fetus, and the ridge patterns, they stay the same. They just get bigger as you grow. Now, what makes fingerprints work so well is that each ridge on the skin has pores, and the pores lead to sweat glands. So then sweat, okay, so liquid comes out of those pores, and that's what's going to lead to us being able to leave a fingerprint. Okay, so epidermis, dermis, the dermal papilla is in between them. Okay, the papilla develop when you're a fetus, okay, and they stay the same. Okay, now, when the finger touches a surface, perspiration, okay, so sweat comes from the sweat glands. And when we touch things, okay, so when we touch our hair has other oils in it. So we get more oils on our hands, and then when we touch something, we leave a fingerprint, okay, so, or the finger ridge pattern. So prints that are deposited in this manner, so when you leave fingerprints like that, okay, due to sweat and due to the oils in your hair, you can't see them with the naked eye, so those are often called latent fingerprints, okay, so they're invisible. You can't see them without doing something to them. Okay, so this is a cross-section of human skin, and the epidermis is the top layer, which is a whole bunch of cells. This picture doesn't show it like that, but it's layers and layers of cells. And then the papilla are underneath of them, and the papilla are kind of like waves. Okay, and everybody's waves are different. Okay, below that is the dermis, and in the dermis, that's where you're going to have the sweat glands. Okay, so there's sweat glands in there, and the liquid is going to leave the sweat glands through ducts, and then the ducts will lead to the pores, the sweat pores that are on the surface of the epidermis. I hope that makes sense. Okay, so we have the epidermis, then we have the papilla, and then we have the dermis, and in there, that's where the sweat glands are. And the sweat glands have ducts, and the ducts take the sweat out to the top, to the surface. And then the nerves are down in the dermis too, so that you can feel things. You can touch them, pick stuff up, feel pain. Okay, now fingerprints are divided into 3 classes based on what their pattern looks like. Okay, so they use the acronym LAW, so LAW. So we can have loops, we can have arches, and we can have whorls. So 60 to 65% of the population have loops, 30 to 35 have whorls, and about 5% have arches. So loops is the most common feature, and then whorls, and then arches. So maybe LWA, if you wanted to remember them in order. So, okay, now a loop must have one or more ridges that are, I'm reading this instead of explaining it. Okay, so they're going to enter from one side of the print, and they're going to curve around and exit from the same side. Okay, so they enter and exit from the same side. Okay, now if the loop opens towards your little finger, it's called an ulnar loop, and if it opens towards your thumb, it's called a radial loop. So it just depends on the direction of the loop. Okay, so the loop is going to come, it's like a wave, and the wave starts on one side and exits on the same side. Okay, now whorls are divided into 4 different groups. So whorls, what makes them special is they're round. Okay, so whorls are round. They're more like a circle. Okay, so we have plain whorls, we have a central pocket loop, we have a double loop, and then we have an accidental. Okay, so a plain whorl and a central pocket loop, they have one ridge that makes a complete circle. Okay, so a plain whorl tends to look like a bullseye, so it's got circles inside of each other. So a bunch of circles inside of each other, that's called a plain whorl. And then a central pocket loop is, they say it looks like the eye of a peacock. So if you think of a peacock feather, it's a loop, but inside of it, there's not a bunch of little circles inside. There's just more of an irregular pattern inside of it. Okay, now a double loop, it kind of makes sense, right? There's two loops in one fingerprint. And then an accidental has two or more patterns, or it's a pattern that doesn't really fit into a category. So an accidental could be a loop and a whorl, or a loop and an arch. And we haven't talked about arches yet. So accidental is a little bit different. It's just not normal. Okay, so a double loop could have a loop. They're describing it as a yin and yang sign. So if you guys remember, that's like the black and white. It's a circle, and then it kind of, I don't know, how do you describe it? It's a circle, and it's divided in half, and it's not divided in half exactly equally. It's kind of like it has a wave in between it. So a double loop kind of goes like that. So there's one loop coming one way, and then there's another loop going the other way. So I know we'll kind of have to explain it. Okay, then accidental. Accidental, it has a couple different kinds of patterns. So it looks like an accident. So it might have loops, but the loops are not all going in the same direction. They're going in a bunch of different directions. So it's really irregular looking. It's not like a circle. It's not like a wave. It's like a mishmash of waves. Okay, now arches, which are like the kind of the easiest to see, are actually the least common of the general patterns. So there's plain arches and there's tented arches. So the plain arch, it's just the ridges are entering from one side and then they exit the opposite side. So just like a wave. So just think of a wave going across. A tented arch is, it's a wave, but in the center, the wave spikes up. Okay, so it goes up. So they say the ridges meet at an angle that is less than 90 degrees. So it goes up. So a plain arch just kind of looks like a wave going through, going by you. A tented arch, the wave spikes up real high and then comes down. Kind of looks like a tent, if you had a tent stake going up in the middle of a triangle tent. Okay, now there's this process, a 4-step process to identify and individualize a fingerprint. Okay, so four different steps. So there's analysis. They say ACE-V. Okay, so ACE-V. So analysis, comparison. Then when you compare, you're going to compare the question print at 3 different levels. Then you're going to identify, and then you're going to verify. Okay, so the verification is the idea that you're not counting on just one person to examine it. You have to have like a validator. There's got to be a second examiner that's going to come in and look at it. So analysis, you're going to, well, here I have it on. Okay, so analysis is they're going to look at the first print, and they're going to look at look at the first print, just make sure everything is okay, and then they're going to start to get ready to put it into comparison. Okay, and then at the comparison stage, there's 3 steps. So comparison stage, okay, so analysis is 1, so they make sure everything is okay. Number 2 is they compare. Number 3 is they identify. Okay, so they're going to say, yes, it came from the same source. No, it didn't come from the same source. So then they could exclude it. Okay, They could also say it's inconclusive. We didn't get enough of it. Okay, and then 4 is the verification, where the second person comes in and says, yes, I agree with you, this matches, or no, this doesn't match. This is where I think it's different. So analysis is first. Okay, so what they're going to do is they're going to do general, wait a minute. Okay, wait a minute. Hold on, I'm going. So here are the 3 steps. So they're going to look at the general ridge flow and the pattern configuration. Okay, so they're going to look for loops, they're going to look for whirls, they're going to, see if they have arches. Then level 2 is they're going to compare the minutia. Okay, so they're going to start comparing the little teeny tiny, the smaller things, like is it bifurcated, where do the ridges end? And then level 3, they're going to start looking for pores, creases, scars, other things that are on there that might be permanent. Okay, so during the comparison stage, they're comparing. Okay, so they're looking at the latent print, and they're looking at the print that they might have got from the suspect. Okay, so they're comparing them. They're actually looking at both of them. Okay, so these things on this slide, level 1, level 2, and level 3, they go with comparison. Okay, now the book talks about this primary classification. Okay, and this is the system of how they organize it mathematically, so they can take something that you can see and make it quantitative so that you can understand it. Okay, so the primary classification is how they do it. Okay, so it's part of this original Henry system, which the Scotland Yard was using in 1901. Okay, and then they kind of figured out a way to assign numbers to it. So this it's kind of interesting, but I could see how it's actually really confusing. So you have to understand like those classes, right? So you need to be familiar with loops, whirls, and arches, and then you can assign numbers to those things. Okay, so what they do is they have a way that they pair the fingers up. So fingers are paired up, and they place one finger in the top of a fraction and the other in the bottom. And it has it written in the book, but I don't expect you guys to memorize it. So they might put like the right index finger is over top of the right thumb. Okay, and then the right ring finger is over top of the right middle finger, and so on. Okay, so that they have all of these fingers compared, okay, or set up in these equations. And then what they do is they look for the presence or the absence of a whorl pattern. Okay, so they look for whether a whorl is there or not. So we're going to classify. This is how the FBI does it. It's called primary classification. It's based on whether you have a whorl or not and comparing your fingers. If a whorl is there, like in the first pair, it gets a value of 16. On the second pair, it gets an 8. On the third pair, it gets a 4. On the fourth pair, it would be a 2, and on the last pair, it would get a 1. Okay, so they take your fingers, they look at these patterns, and they assign them a number. Okay, so the numbers are kind of random, but because they do it consistently, it's a way to match things up. Okay, so then any finger that has a loop or an arch gets a 0. And then what they do is they total everything up and they add a 1 to the numerator and the denominator, and then it gives you a fraction. And that fraction is the primary classification. So it's really kind of like an arbitrary system, but because they use it consistently, you can come up with a number for different people, and then you can try to match them that way. So it gives you a way to match them without having to start comparing like thousands of things with your eyes. Does that make any sense at all? It's a way to put the data in the database. Okay, so the eye miracle. Okay, so they found that 25% of the population falls into 1/1. So that would mean that all their fingers have either loops or arches, right? Because your fingers that have those are 0, and you add 1. So that would mean that everything would have a 1 or a 1. Okay, a fingerprint classification system cannot identify the person unequivocally. Okay, so you can't just use these numbers to identify them. Somebody has to look at the fingerprints and they have to match them up and match up all the minutia. Okay, now APHIS, I'm going to sneeze. APHIS is the automated fingerprint identification system. So we should have that written on here somewhere. So it's the automated fingerprint identification system. So APHIS is based on the idea that the computer can scan and digitally encode the fingerprints so that the computer can process hundreds of thousands of them in a second. Okay, so it's the idea that a person doesn't have to do it, the computer can do it. Okay, so APHIS aids in classifying and retrieving fingerprints by converting the image of a fingerprint into digital minutia. Okay, so when a search is complete, what happens? Okay, so you can't just say, oh, it matched in the computer, they're guilty. What they'll do is they'll say they match in the computer, and then a person, a trained fingerprint expert, is going to visually compare what the computer said. Okay, so it's not like it comes up in the computer and then they go bring them in. They probably comes up in the computer. Maybe they could, if they have more information, they could bring them in and then they could match it. Okay, so somebody has to look at it. Okay, now APHIS systems. Okay, so different places have different systems. Most of them, and different companies develop the databases. They should all feed into the FBI's database, but what happens is because states and localities have their own system, they can't all communicate with each other. Okay, so they can't all share information, but they should all be able to talk to the FBI. Okay, so now we'll talk about latent prints. Oh, and I didn't talk about live scan. So live scan is a way that you can actually put fingerprints straight into APHIS. So it's a inkless device, so it digitally images fingerprints and palm prints. So you put them on like a glass screen. It's almost like making a photocopy, okay? And it goes straight in. So live scan, it's a digital capture device. Okay, now latent prints. So a latent print is an invisible fingerprint, so it's left from the oils on the skin. Okay, so visible prints are ones that you can actually see. So visible prints happen if somebody had blood on their fingers or paint or grease or ink. So somehow they had something on their fingers and they put it down. Okay, now, so that's visible prints. Plastic prints are impressions that can be left in something soft. Okay, so if you left it in clay or you left it in putty or wax or soap or dust, those are called plastic prints. Okay, finding visible or plastic prints at a crime scene usually shouldn't be a problem because you can actually see them, right? So they're visible. Okay, now the next section talks about porous and non-porous surfaces. So a non-absorbent surface would be something like glass, mirror, tile, painted wood. Okay, so something that it's not going to take up water, but something that's porous would be paper, cardboard, fabric, cloth. Okay, now, latent prints that are deposited on a hard or non-absorbent surface are usually developed by adding powder to it. So using a brush and putting powder on it. And then porous surfaces, usually you have to treat them with a chemical. Okay, so we have a list of chemicals and powders. Okay, so powders can come in a variety of colors, and usually you want contrast, right? So you want it to contrast with what you're up against. Okay, you can use a brush, or there's this magnetic wand. It's based on a magnet. It doesn't have fibers on it. Okay, so the powders are going to stick to the body oils or the sweat. And the most common powders that are used are black carbon or aluminum dust, which looks gray. Okay, now another way to do this is to use super glue. Okay, so super glue is made out of this cyanoacrylate ester. Okay, so what it does is this cyanoacrylate ester is a chemical that interacts and with the oils in the fingerprint so that you can actually see it. So what you do is you take the super glue and you can fume the latent prints. So they could be put in a box, and the super glue is a fume, like a gas of the super glue, is put into there. So super glue fuming develops latent prints on non-porous surfaces such as metals, electrical tape, leather, and plastic bags. Okay, so what happens is the fumes from the glue adhere to the print, and usually it looks white. The latent print will look white. You could use a fuming chamber, or there's also a little handheld wand, and it comes with like a little cassette or a cartridge that's got the super glue in it, and that heats it up and kind of like blows it out on it. Okay, now another way that you can visualize latent prints is they can be treated, fingerprints can be treated with chemical that you can expose to a light, so like a laser light or a quartz halogen light or xenon arc or these other indium arc light sources. Okay, so they're called alternate light sources. So you put some chemicals on it, and when you add these light sources, it causes the fingerprints to fluoresce. Okay. Okay, another way, a way to detect prints on porous surfaces is iodine fuming. So iodine comes as crystals, and what happens is the crystals will sublimate, so they'll turn from kind of like an ice cube. If you had an ice cubes in your freezer, and they sit in there for a long time, and you go in and all the water's gone, right? It's not, the ice cube is gone because the water sublimates, so it gets turned into water vapor. So the iodine crystals will do that. So you have the iodine crystals, and the crystals will sublimate, and it kind of turns into, well, it turns into a gas, and then that's going to interact with the latent prints. Now, iodine is not permanent, so it's going to fade. So you have to take pictures of them before they fade, or you have to add some other chemicals to it. Okay, another chemical that's used is ninhydrin. So ninhydrin, what it does is it actually binds with the amino acids that are present in the proteins in the sweat. So it makes things look purple or blue, and it's the chemical method of choice. Okay, so it says prints begin to appear an hour or two after ninhydrin application, but sometimes it can take up to 48 hours, or you can heat it up. Okay, another way to detect fingerprints on porous surfaces is what's called a physical developer. A physical developer, so it's they call it physical developer with a capital P and a capital D. It's a silver nitrate based liquid, and what happens, it's good for things that were wet at one time. Silver nitrate makes things look gray or silvery kind of. So this is kind of maybe like a last resort. So you try super glue, you try iodine, you try ninhydrin, and then you could use the physical developer, which is the silver nitrate. Okay, now there is a way, like if you want to use all three of those chemical methods, they've come up with a protocol to do that. Okay, so first thing they do is they fume with iodine, and then they treat with ninhydrin, and then they use the physical developer. So I guess you could say you do it in alphabetical order, right? So iodine, then ninhydrin, and then physical developer. So iodine, ninhydrin, and physical developer would be the order that you would do it in if you wanted to use all three. Okay, now preserving prints. So if the object's small enough that you can move it without destroying it, you should preserve it in its entirety. But you should take a photograph before you do anything to it. Okay, prints that are on large immovable objects that have been developed with a powder, you can lift the prints with tape, and then the tape's placed on a card so that you have contrast with the powder. Okay, digital imaging is just like you're going to take a picture and save it as a computer file. You can enhance things so that you could accurately analyze it, which that always kind of scares me when things get digitally enhanced. I never trust anybody. And then, but if they're digital, then you could compare them, right? You could compare them easily, comparing them side by side. Okay, and that's the last slide. I know I went through that fast, but I hope it's okay. I hope you get what you need out of it.